Good day, students. In this lecture, we are going to see how to compute 8-point DFT. I am going to teach you a very simple way of reducing the number of time consuming in finding 8-point DFT of a sequence. Let's solve this problem now. The statement of the problem is compute 8-point DFT of the sequence x of n is equal to -1, 2, 2, 2, finally -1. Okay. Starting with the solution, here the given value of n is 8. Since it is mentioned in the problem that it is 8 point, we have to consider n to be equal to 8. And if I want to find this 8-point DFT, I must have 8 number of samples in my given input sequence. Only if I have 8 number of samples in the given input sequence, I will be able to find 8-point DFT. But if you look at here, the given sequence x of n has only 5 samples. So, in order to make its length to be equal to 8, what we are going to do is, we have to pad 3 zeros, and this has to be padded at the end of the sequence to make its length equal to 8. Now look at the sequence. X of n is equal to -1, 2, 2, 2, -1. With this, all 5 samples we have written as mentioned in the problem, and we have padded 3 zeros to it to make its length equal to 8. Now once this is done, we can start solving this problem by writing the formula for DFT. So the n-point DFT in general is given by x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi k n by capital N. The range of k is from 0 to n minus 1. The very first step while solving this problem, we have to substitute the given value of n in the above equation. So substituting n, what we are going to get is x of k is equal to sigma n is equal to 0 to 7, because n minus 1 is here, n is 8, so 8 minus 1 7, x of n e power minus j 2 pi k n by capital N. The value of n is 8, we have mentioned it as 8 here. Now this is 2 and this is 8, which can be very well simplified, and we will get pi by 4, pi k n by 4. The range of k will be from 0 to 7. The next step, we have to expand the above equation. For different values of n, this summation ranges from 0 to 7. Now we are going to expand it for different values of n from 0 to 7. When we substitute n as 0, it will be x of 0 e power, when n is 0, it becomes 0 e power 0. Plus, when n is 1, it will be x of 1 e power minus j pi k. We have only pi k by 4 here. So pi k, n value is 1, so pi k by 4. Plus, when n is equal to 2, it becomes x of 2, we have written it here, x of 2 e power minus j pi k by, 2 pi k by 4, because the range of n, value of n is 2 here, so 2 pi k by 4. Plus, the third value, next value of n is 3, so x of 3 e power minus j 3 pi k by 4. N value was 3, so it becomes 3 pi k by 4. Like this, you have to expand it till x of 7. X of 4 e power minus j 4 pi k by 4 plus x of 5 e power minus j 5 pi k by 4. Simply we are substituting the value of n here and here in this equation. Plus x of 6 e power minus j 6 pi k by 4 plus x of 7 e power minus j 7 pi k by 4. Now we can cancel the terms that can be simplified by 2. So here this is 2 pi k by 4, it becomes pi k by 2. Likewise, this is 4 pi k by 4, it becomes e power minus j pi k. Here it is 6 pi k by 4, we can reduce it as e power minus j 3 pi k by 2. Next what we are going to do is, we are going to substitute the different values of x of n. It's given in the problem that x of n is minus 1, 2, 2, 2, minus 1, 0, 0, 0. And now this is for x of 0, x of 1, 2, 3, 4, 5, 6 and 7. So x of 0 is minus 1. We are substituting it here as minus 1. E power 0 is 1. So it is minus 1 into 1, 1. Next is x of 1. X of 1's value is 2 in the given problem. So we are writing 2 here. And you have a complex term which is e power minus j pi k by 4. We know that e power minus j pi k by 4, e power minus j theta in general is cos theta minus j sin theta. So e power minus j pi by 4 can be written as cos pi k by 4 minus j sin pi k by 4. And x of 2's value is 2. We are substituting it here as 2. We are left with the exponential term. After simplification, it is e power minus j pi k by 2. If we expand this, cos pi k by 2 minus j sin pi k by 2. Likewise, x of 3 is also 2. So 2 into e power minus j 3 pi k by 4, which can be expanded as cos of 3 pi k by 4 minus j sin 3 pi k by 4. Next value is x of 4. X of 4's value is minus 1. I have written it as minus 1 here. And the complex term involved is e power minus j pi k, which can be expanded as cos pi k minus j sin pi k. Next term is x of 5. X of 5 is 0. So 0 into the expansion of this complex, which is cos 5 pi k minus j sin 5 pi k by 4. Rest of all the terms, that is 6th and 7th sample also is 0. So 0 into e power minus j 3 pi k by 2, which can be written as cos 3 pi k by 2 minus j sin 3 pi k by 2, plus 0 cos pi 7 pi k by 4 minus j sin 7 pi k by 4. Of course, the last 3 values are going to be 0. As it is getting multiplied by 0, it will be 0. These 3 sample values will be 0 now. Moving forward, the next step, we are going to simplify the previously written equation. The previously written equation, we had minus 1 plus 2 cos pi k by 4 minus j sin pi k by 4. We are going to multiply this 2 inside this bracket terms. So we can write it as 1 minus 1 plus 2 cos pi k by 4 minus 2j sin pi k by 4. Likewise, the next term here is 2 cos pi k by 2 minus 2j sin pi k by 2, which we have written it here. 2 cos pi k by 2 minus 2j sin pi k by 2. So in all the terms, we are multiplying this 2 inside. So 2 cos 3 pi k by 4 minus 2j sin 3 pi k by 4. We have written it here. And the last term is minus 1 cos pi k minus j sin pi k. So it is minus 1 cos pi k. This minus 1 into minus j becomes plus. So plus j sin pi k. The remaining 3 terms are 0. 5, 6 and 7th sample are 0 here. After this step, we are going to group the real and imaginary parts separately. So, if you look at or if you compare this equation, here the real terms are minus 1, 2 cos, 2 cos pi k by 2, 2 cos 3 pi k by 4 minus cos pi k. So we are taking the real terms separately here. Minus 1, 2 cos pi k by 4, 2 cos pi k by 2 plus 2 cos 3 pi k by 4 minus cos pi k, plus all the imaginary terms are going to have j. So we are taking j as common, plus j. I am going to write the imaginary parts here. The imaginary parts are this one. Here I have an imaginary part. This is an imaginary part, and this is also an imaginary part. So there are going to be 4 different terms. First term is minus 2 sin pi k by 4, because j we have taken as common. Minus 2 sin pi k by 4. Minus 2 sin pi k by 2. Minus 2 sin 3 pi k by 4. We have written it here. Plus sin pi k. Now we have grouped all the real terms and the imaginary terms. Let's do it in a very simple way in our calculator by storing the real terms separately as an equation and the imaginary terms separately as an equation. Now what we are going to find is, we have to substitute the value of k from 0 to 7. When I substitute k as 0, I am going to get the value of this for k is equal to 0. Likewise, I have to increase the range of k from 0 to 7 and substitute its corresponding values here. Find the real term separately and the imaginary term separately. Once the real and the imaginary terms are determined, we are going to add it together to find the final answer. Let us look into the procedure of how to do this in calculator. Now calculating the values of real terms. I have written the steps for calculating the values of real terms. The same procedure you have to repeat for calculating the values of imaginary terms. Before that, let us form a table like this. This is for mentioning the values of k from 0 to 7. And here I am going to write the real parts value. And in this column we are going to write the imaginary parts value. And this is going to be sum of real and imaginary, because these two terms has to be the real term and the imaginary term has to be added together after multiplication with this j. So this is sum of real and imaginary. Let's form a table like this. The range of k should be from 0 to 7. After forming this table, in your calculator, the very first step that you have to do is, you have to keep the calculator in radians mode. Don't forget this. This has to be kept in radians mode. As a second step, you type the below equation as such. Now if you look into this equation, this is nothing but the equation that we got for the real terms alone. We have grouped the real and the imaginary terms separately, is it not? And in the real term equation, we have got 1, 2, 3, 4 and 5 terms. These 5 terms I am entering in the calculator as I have written here as it is. That is first minus 1 plus within a square bracket 2 cos of pi a divided by 4, close this bracket, close the square bracket, plus next term 2 cos of pi a divided by 2, close these two brackets, plus 2 cos of 3 pi a divided by 4, close the bracket, minus cos pi a. In my original equation, the variable that I have considered is k. But while typing this equation in the calculator, this k will not be available. The variable k cannot be typed in the calculator because it is not available. So what we are doing is, instead of k, we are making use of the variable a in all the places of k. And how to type this a in calculator is, you can press alpha, you can locate this alpha button, press it, and then a. After pressing alpha, you can press A. So this variable A will be present on the screen of the calculator if you do this procedure, that is press alpha and then A. Wherever you have K, you are pressing alpha and A and obtaining this particular equation. Now once this equation is typed completely, then you press CALC. There will be a button, CALC button in the calculator. You press this button. Once this button is pressed, this entire equation, that is entire terms, will be stored as an equation in the calculator and it will ask for the value of A. So once the CALC button is pressed, calculator will ask you for the value of A. And we know that the range of A is from 0 to 7 because we have replaced only K as A. The range of K is replaced as A. So the range of K is from 0 to 7. Now A also has the range from 0 to 7. Now, once the calculator asks for the value of A, you type 0. Starting from 0 you have to type. Initially you give 0 and press equal to. Once you type 0 and press equal to, this calculator will give the real term value for A is equal to 0. And you can make a note of this value for K is equal to 0 in the real column. For K is equal to 0, if I press equal to, I am getting the value as 4. Next what I have to do? Again I have to press equal to. Again I have to press equal to. Once this equal to is pressed again, it will ask for the value of A. I have to give the value of A as 1 and press equal to. Once this is being done, the value of this equation for K is equal to 1 will be displayed on the calculator. I have got the value as 0. Next what we are supposed to do? Again we have to press equal to. It will ask for the value of A. We have to give the value of A as 2 now. Once 2 is typed, you press equal to. It will display the value of real value for K is equal to 2. I have got it as -4. Repeat the same procedure by pressing equal to again and again and giving the rest of the values for A. After pressing equal to, you have to give the value of 3. Press equal to, you will get the value 0. Next again for 4, 5, 6 and 7. So we are tabulating all these values of K from 0 to 7. These are the real values. Now we have to make use of the same procedure and store this equation of imaginary terms in the calculator. Is it clear? We have completed only the real terms. Now we have to store this imaginary terms in the calculator as an equation and follow the same procedure. Again here we cannot type K, so we are going to make use of the variable A by pressing alpha and A. By repeating the same procedure as we did for real parts. In this place, we are going to get the equation for the imaginary terms. We are going to follow the same procedure and we are going to tabulate the imaginary term values. Now these are the range of imaginary terms for K is equal to 0 to 7. We have got the real term and the imaginary terms as a tabular column. Once real and imaginary terms are determined in the calculator, finally we have to find the sum of real and imaginary. While writing the sum of real and imaginary terms, we have to multiply the imaginary terms with 0 and write, because we have plus j term here. With all the imaginary terms we have to multiply j, and this second of it has to be added to the first of. Okay, so This is 4 plus 0j. For k is equal to 1, it will be 0 minus 4.828j, which is good for the value of which I am getting it as minus 4.828j. For k is equal to 2, it is minus 4 plus 0j. So it is minus 4. For k is equal to 3, 0 minus 0.828j. So 0 minus 0.828j, value is minus 0.828j. For k is equal to 4, minus 4 plus 0, j, so it is minus 4. For k is equal to 5, 0 plus 0.828j, so it is plus 0.828j. For k is equal to 6, minus 4 plus 0j, which gives us minus 4. For k is equal to 7, it is 0 plus 4.828j. So 0 plus 4.828j gives us the value 4.828j. So by this way, we can find 8-point DFT in a very simple manner if you are able to store this real parts and imaginary parts separately as equation in the calculator and finding its values separately. Finally, we have to club it together. We have to sum it up together. So final answer for this problem is going to be x of k is equal to minus 4 minus j 4.828 minus 4 minus j 0.828 minus 4 j 0.828 minus 4 j 4.828. And one interesting thing that can be noted here is while finding DFT, that is 8-point DFT, our x of 1 and x of 7 will be complex conjugates of each other. If you look into this, this is 0, this is 1, 2, 3, 4, 5, 6 and 7. So when we observe this x of 1 and x of 7, this is minus j 4.828 and this is plus j 4.828. Though both these are complex conjugate terms. Likewise, x of 2 will be the complex conjugate of x of 6. X of 2 is minus 4, x of 6 is also minus 4. Since there are no j terms involved, we are getting the same value here. For real terms, its complex conjugate will also be the same. So minus 4, minus 4. Likewise, x of 3 will be the complex conjugate of x of 5. Now this is x of 3 and this is x of 5. We can very well notice that this is minus j 0.828 and this is j 0.828. So by this way, we can also check the answer, whether the answer is correct or not. Always it will be the complex conjugates. So we can check our answer too.